friends, today I'm going to talk about PQRST different waves. These you might have seen on the ECG graph papers if you are working in the medical fields. So talking about PQRST, what they actually denote. So P you might be knowing, it denotes the atrial depolarization. QRS is a single complex. So Q is a single wave, R is a single wave, S is a single wave which you can see on electrocardiogram. And these three waves collectively join together and they make one complex that is known as QRS complex. And this is representing ventricle depolarization. Then moving on to the T wave, it represents the ventricle repolarization. And this is a U wave, you might be knowing or not, I don't know. It's a U wave, its height is 1/4 of the T wave. So this is the basic knowledge which all the medical students might be having now. So this is a normal heartbeat, everyone knows.
The origin of U wave is not known, but there is an hypothesis that U wave originate due to repolarization of interventricular septal muscles.
Now next, moving on to the different segments and different intervals which you might have seen while reading your books. Now what does interval means? Interval means a single event. So let us consider interval or event related to atria. So we know the atrial depolarization starts from here, from where do the P wave starts and end in between somewhere where there is R wave. So atrial events are considered from this to this, means this is an PR or PQ interval. It's PQ interval. Then considering the events related to ventricles. We know the event related to ventricles starts from here. Ventricle depolarization starts from where Q wave starts and end where the P wave ends. This whole event related to ventricles starting from the Q and ending at the T, at the end of T wave. So this is considered as QT interval. Now this is all about the intervals. Interval related to atria, that is PQ interval. Interval related to ventricles, that is QT interval. Now let us consider about the segment. So firstly, what does segment mean? Segment means a distance between two waves. So here we can see where do the P wave ends and Q wave starts. So it is a distance between two waves. So this is a PR segment. Then we consider the ending of the wave S and starting of the wave T, means this portion. This portion is known as ST segment. So here you might have seen that I have always considered R because Q is a very small wave over the time interval. Hey, let me tell you, when we see the ECG graph, this is the amplitude or voltage difference. And this is the time over the ECG graph. Here I'm going to talk about different segments and the related events to them. So first we have discussed about the PR segment, that is this one or this one. What does this segment denote? As we know, the electrical impulses starts from the SA node and they travel to the AV node, which is present in the intraatrial septum muscles. This is the time interval which do the electrical impulses take to travel from the SA node to the AV node. And after they have reached to the AV node, they will spread the depolarization into the ventricle. So this is a ventricle depolarization. So this is a time interval, not an event, I must say. This is ST. So what does this ST denotes? ST denotes the time period which the ventricles takes for contraction. As we know, this is a ventricle depolarization. The ventricles doesn't go suddenly and contract. They take certain time to get depolarized, and after that, they are going to contract over this period.
Here, atrial systole relates to atrial contraction and ventricle systole relates to ventricle contraction.
So this is the raw heart which I have drawn for you. This represents right atrium, left atrium, right ventricle, and left ventricle. And now I'm going to erase it. Now considering the conducting system of your heart, which usually starts from the SA node And that's why the normal heart rhythm is known as sinus rhythm, because all the normal heart rhythms, they start from the SA node. So from the SA node, the electrical impulses, they travel very easily to the area, right atrium, and then to the left atrium. So the electrical impulses take a little bit more time, certain milliseconds, to travel to the left atrium. So there is a little variation in the P wave, which we may not have noticed. That is, P wave is bi-humped. How it is, it's like this. So this is a P wave. It is having a little bit hump over there, a downward deviation over here. So it's a downward deviation over here. So that is because the depolarization of the right atrium occur first, which represent this first bump, and the depolarization of the left atrium occur after a few milliseconds after the first one occur. So that represent a second bump.